Section 1.8, Example 2 on page 72, we have a solution of a compound inequality involving and is any number that makes both inequalities true. One way you can solve a compound inequality is by separating it into two inequalities. So for example 2, it says what are the solutions of -3 is less than or equal to m minus 4 is less than -1. Graph the solutions. So this one actually said that you can break it apart into two, but there is a quicker way to solve this where I like to use the railroad track. The railroad tracks help us see that we have 1, 2, 3 sides, and our goal is still to get m all by itself. Right now we have -3 is less than or equal to m minus 3, which is less than -1. I want to get the m by itself. Right now this minus 4 is in the way, so what I'm going to do is add 4 to all three sides. -3 plus 4 is 1. -4 plus 4 is a 0 pair. Bring down our m. -1 plus 4 is 3. Since we were adding, we just bring down our symbols. We don't flip anything. So we have 1 is less than or equal to m, which is less than 3. Since we have less than or equal to next to our 1, we have a closed dot on 1. Since we have less than 3, we have an open dot on 3. And because this is and, we know that we're going to draw our line right in the middle of the two. If you're unsure, you can always check less than 3 is to the left, greater than 1 is to the right, and they meet in the middle. The book does this a different way. So they split it up into -3 is less than or equal to m minus 4 and m minus 4 is less than -1. Then they just add 4 to both sides for each inequality. You're left with 1 is less than or equal to m and m is less than 3. You can put it back together to get what we had. 1 is less than or equal to m, which is less than 3, and we get the exact same graph. On page 72, we have number 3, solve each compound inequality, graph your solutions. We have -4 is less than k plus 3, which is less than 8. You can solve this either way. Make sure to graph your solution.